All right, ladies and gentlemen, welcome back to CodeCademy. We haven't done this in quite a bit, and they have a wonderful section called Asynchronous JavaScript. This is going to be key for anyone who is serious about being a web developer to understand how to use promises, to be familiar with the async away syntax, and just generally fully understand what it means to write asynchronous code. So we have here about a 1-hour introduction course to get you familiar with some of the basics regarding those subjects. So let's go ahead and jump into it. Hey guys, I want to take a moment to recommend Dev Mountain Coding Bootcamp to you. Dev Mountain's been a long-term sponsor of mine. I appreciate their support as I've helped grow the channel and tell everyone about their great facilities. I've actually been to their Provo, Utah campus, and it's beautiful. So if you're interested in a full-stack JavaScript bootcamp, they provide housing alongside the tuition, so you can get up and go today. They're one of the most affordable bootcamps in the world, in the States, and I highly suggest you check them out at devmountain.com. All right, so let's go ahead and jump into this asynchronous stuff, right? So, a very quick rundown of what these next two slides are is about promises and asynchronous code. So most of us who are just getting started in writing JavaScript or writing any sort of programming language is used to synchronous code, meaning it goes step 1, then step 2, then step 3, then step 4, then step 5, and we wait until step 1 is done to move on to step 2, and we wait until step 2 is done to move on to step 3, etc., etc. Now that's synchronous code. Asynchronous code means that we're okay having certain parts of our code move on. So step 1 may happen, and then step 2 triggers, but maybe it's going to an API and there's a delay, and we're saying, well, this is really encapsulated and doesn't affect any other pieces of the code for the time being. So we're okay, hey, just go ahead and do your thing. We're going to keep moving on, right? Because it's not going to affect the other aspects. That's what it means for the code to be asynchronous. And so promises are the way that we handle this in JavaScript. Promises allow us to, as they say here, are objects that represent the eventual outcome of an asynchronous operation. So a promise has 3 states: pending, meaning it's still doing its thing; fulfilled, meaning it has completed; or rejected, meaning it has failed. So what you really need to know is that you're going to have the resolve means it's completed, and the rejected means there was some sort of error. Pending means it's still going on. So you'll see here we have this inventory object, and we're going to create a new promise. You see we have my new promise here, and then we're going to create essentially a callback function that has 2 properties: resolve and reject. Remember, resolve is the success, reject is the failure. And then we are constructing a new promise. If you're not familiar with constructors, this essentially just means that we're creating a new promise, creating a class, if you want to think of it that way. So let's go ahead and continue on. So they want us to create a promise here, or create a we're going to create a promise representing ordering sunglasses from an online store. First, create the function myExecutor. Later on you'll pass this into a function, so we're going to do something very similar to this. So we're going to create a callback function, const myExecutor is equal to arrow function. Go ahead and put it there. And the first parameter will be resolve, and the second parameter will be reject. And what we want that to be is have 2 parameters: resolve and reject. Check if sunglasses property has value greater than 0. So we're going to do our logic now, right? So if inventory.sunglasses is greater than 0, we want to resolve, and in here we're going to put what it is that we want to return: the sunglasses order processed, period. Else we want to reject it, saying that there was an issue because in this case we don't have enough inventory, right? So there's an error, an issue, and say that item is sold out, period. Now let's go ahead and check our work. Syntax error. Oh, let's try it one more time. Excellent. So we have our initial setup to go in to be executed in the promise once we pass it over. So now we're going to create a function, and in here we have no parameters, and what we want function order sunglasses to do is return a new promise. And what are we passing into it? Our callback function for it, my executor. Excellent. And now we're going to create a variable to assign that to. And we're going to call that our order promise. We're going to set this equal to the return of order sunglasses. And this whole function returning a new promise, so this isn't really necessary. I just think they want to show you that, you know, how to use them interchangeably use them with functions, right? It's just like any other JavaScript that we're doing. At the bottom of the app.js, we want to console.log order promise, so we can see the result. And go ahead and check our work. To run the app.js program, you need to type node app.js. So this will go ahead and launch the node server that it's using, and you'll see here that the sunglasses order has promise is what we're getting out of our promise. And the reason for that is because it was successful, right? There's 1900 on there, and thus it resolved properly and it didn't throw an error. Now we're gonna do a little bit of looks like set timeout. Moving forward, so as I mentioned, synchronous code takes time, right? It takes time in the operation. We're firing off an API. Set timeout is another great way to simulate that, because we can actually force time upon the system. If you're not familiar with set timeout, it takes a callback function for the logic followed by an amount of time for it to be delayed. And so it looks like they want us to make this feel much more async than it did a moment ago, because there was no time associated with it. So create a function using STO. All right, so function using STO. Your set timeout is STO. Inside the function body, it should print a string to the console. This can be any string you want, as long as it's not as long as it's not that. So cool, excellent. Check our work and move on. Should be pretty straightforward so far. So using STO, and then we're just going to log something eventually. Now let's invoke set timeout function. Remember, set timeout is 2 parameters. Invoke set timeout with your using STO as the first argument, and a number between 0 and 3000 the second argument. So as you can see again up here, we have our set. Where's our set timeout example? So set timeout. And in here, we already have a function. So we're saying using STO. And then we'll say it's in milliseconds, so we'll say 2000 there. So that'll be 2 seconds. Go ahead and check our work real quick. I see. They wanted it as a callback function. This isn't a callback function. My mistake here. So we need this to be a callback function, which is easy enough. All we gotta do is throw arrow functions on this, like so, and assign it as a variable, so it can be a reference. And then we just go ahead and make that const. Check our work. I wonder what the issue is. It seems that we're doing it correctly. Silly me. I do this every time I use set timeout. And it should be a lowercase o. There we go. All right, so now what's going to happen is you're going to notice a 2-second delay on our code. So we're passing our callback function into the set timeout that's going to delay it 2 seconds. This is going to simulate asynchronous code running. And so what will happen is it's going to log this first line of the application, console log. It's then going to log this, and then it's going to log this. And that the reason for it is because we're treating it async. We're saying, hey, log this. And we're saying, oh, this is asynchronous right here, this set timeout. Let it do whatever it's going to do. And then we're saying, okay, cool, log this. And then 2 seconds later, oh, bam, we're done. All right, what do we need to do? We need to log that. So you'll notice that we'll have 2 logs, first, last, and now async example. And that's an example of exactly that, how asynchronous code is supposed to work. All right, so as we mentioned, the initial state of promises is pending, meaning it's, in the set timeout, those 2 seconds while it's resolving. There's also this .then method, which is how we handle the resolve of promises when it's successful. And then takes in 2 callbacks, or handlers as they like to call them. I've never actually heard that term before. But the success criteria is the first one. The second one is on rejected. Remember, resolve and rejected, resolve and rejected. That's really all you have to remember amongst us. And so you see, oh, cool, resolve and then actions, reject and then actions. And so with the then, it gives us the ability to add additional logic, right? I'll go back to the API example because it's most common. We get data from the API. We just don't want to get the data. Maybe we want to do something. Once we have the data, we want to call 3 functions that are going to map the data accordingly or update aspects of it. And so that's a very realistic situation how we might do that. So then on fulfilled and on rejected functions. So you can call then on functions as I mentioned, and we can do some stuff with it, right? So they're going in very detailed of a lot of stuff they really don't need to by the looks of it. So let's see. Take a look at the provided code. We require a function check inventory. It builds on the logic of the order sunglasses function you wrote in the previous exercise. Check inventory takes in an array representing an order and returns a promise. If every item in the order is in stock, that promise is resolves with the value, thank you, your order was successful. Otherwise, the promise rejects with the value, we're sorry, your order could not be complete. We use set timeout to ensure check inventory promise settles asynchronously. Cool. All right. So it looks like this is the check inventory logic and resolve. All right. So write a function handle success. should have one parameter representing a resolved value. What they like to name it this time? Just resolved value. Okay, we'll do that. Normally I just would put data if it's coming from API or whatever it represents. We'll go with the resolved value. Log the parameter. All right. Everything should be good to go so far. Excellent. Write a function handle failure. Same thing here. And this is also going to have one parameter representing a rejection reason. And so we'll go rejected value, follow with the naming convention, right? So one thing you'll find is that you want to understand conventions and standards in it, and you want your code to reflect that, whatever they be. So let's try and follow the one that's established here. And so we'd want to here log the rejected value, like so. All right, check our work. Cool. Invoke check inventory with order. Attach a then function, pass into a then the two handling zeros callback functions. All right, so let's go ahead and we'll say check inventory. We're invoking the function now, and then we're say that then, and then we'll have some arrow functions here, and we'll have resolve. We wanted to pass in what? So this is our process then? Oh. We wanted to pass in our two handles. Pass in our handle success and our handle failure. Excellent. Cool. Let's go ahead and check our work. Invoke check inventory and then directly chain to the dot then. You can use any white space you like to make it easier to read, but make sure you're double checking your spelling. All right. What did I do wrong? Probably some sort of syntax mistake. Well, our handle failure was good. Our handle success is good. Our then is good. Check inventory is good. Oh, is check inventory taking a value? Is the issue? It looks fine to me. Let's see what they say. They're gonna give us a solution. Oh, I forgot to pass ordering. Whoopsies. So yeah, this check inventory takes in some value. But anyhow, thank you. Your order was successful. All right, and vice versa. If we wanted to change this and go ahead and make that 0, and or actually we don't know how many they have in there, but if it failed, it would have put the reject reason through. So we have our promise that takes in a value that does whatever it does, and then if it's successful, if it's a failure. So this is very cool that they're bringing up separations of concern. So catch allows us to catch the errors that are going to be thrown and separate out that logic quite a bit, which is nice, right? Instead of passing both handlers into one, like we did, we can do .then and .then with a failure handled at the to a first then with success handler. Both cases will be handled. So you can see something like this. We don't care about the white space. So technically, we can pass in, resolve these separately, but it looks kind of weird, right? So instead, what we can do is use catch instead of then, and this is just to catch the error. It's just syntax-wise, much better. So we're going to refactor the function out of the previous exercise, but this time we're going to use catch. Cool. First, invoke the check inventory function. Check inventory function, and we're going to pass in order like so. We haven't really done anything like that, or done anything, but we're going to just call it. Next, we're going to call .then on it, and remember this first one that's coming in here will be our handle success callback, and that will be our success function. One thing to keep in mind is that this is correct. You don't always have to handle the rejection case, should you? Every single time for the most part. All right, and so that's our then, which means our resolve, because it's the first one, and then we're going to catch the error, and in this case we'll handle failure like so, and that will catch our error. And now when we set the sunglasses to 0 and we run our app our node app.js, you'll see it's going to that shouldn't have done it. It should have actually fired off the it should have fired off the catch. That's an issue on their end though. That should have caught it. But anyhow, so you can see that we're throwing the error case in the catch, and that's what's important here. You can also chain multiple promises together. This happens quite often where you need to hit one API to get data from another that you're going to use in another, and so you have to sort of wait on these things and then do so. And so you get these long chains, right? Apparently the chaining of promises together is called composition. I'm not very big on vocabulary, so I did not know that. So we invoke a function first promise. Take a look at the provided code. We check the inventory. So we have check inventory, process payment, ship order. Very realistic example of what would happen in a normal e-commerce platform, right? They each return a promise. Check inventory expects an order argument and returns a promise. If there are enough items in select fill order, the promise is resolved to an array. And the first element of the resolved array value was the same order. The second element of total cost. Process payment expects an array argument with the order. Select enough balance, it will resolve the array. The first element of the resolved array will be the same order, and the second element will be a tracking number. Ship order expects an array argument with the order as the first element, tracking number as second. It returns promise. If you'd like, look at library.js. All right, so there's quite a bit of setup. We set up a promise chain, but it's missing a couple important lines of code. We invoke check inventory with order. So we have our promise here, and we're passing a value to it. Chain with the then function to do it. This then has a anonymous function as its success handler, resolved a value array. So that's typically going to be the data that's being returned back from the promise or the API. But it's missing a return statement. What we want it to return is the process payment method, and I forget what it was supposed to take in, the value. Yeah, so this promise, we're going to pass in the resolved value array, so the data that's coming back from it. And so this is going to hit, this is going to return a promise, and this is going to fire off again. So go ahead and check our work. More spelling mistakes on my end. Check our work. There we go. We have a second then function on the chain. So now that this is successfully completed, we then once on this promise, we want to then, it also has an anonymous value that's going on there. We then want to ship the order with the resolved value array, like so. Check our work. Cool. And now when we go ahead and launch our node app.js, what will happen is a successful, all the items are in stock, the total cost of the order is $35.97, payment processed with the girl, the order has been shipped. So you can see we're doing, all right, this completes, cool, success, this completes successfully, great. Oh, cool, this completes successfully, great. Log and error. So we're chaining these two promises, or three really, because we have the check the inventory with the value that comes back from inventory, saying that it returns a data model, pass that data model in, process the payment with that data, cool. When that completes, go ahead and fire off shipped order, and with the values that we got from the payment for everything go through. So you can see very quickly how this can get a little bit more complex and chained together, but you know, you can kind of leading into this next section, avoiding common mistakes. You can see how you might be able to make some mistakes along the way, right? It's not always the prettiest thing to do nested callbacks like that, but sometimes it's unavoidable, right? So mistake one, nesting promises instead of chaining them. So you notice how we chain them. You can nest them, and that's something, but chaining is usually a bit better. You want to avoid nesting as much as possible. Chaining is a little bit cleaner, a little bit easier to read most of the time. And you can see here, this is what the very same code has now been nested, and it's a little bit harder to read, right? And really, we can chain them together and it'd work just fine. And the second is forgetting to return a promise. Yeah. So you need to return the promise in order for the then to fire off the next then. Otherwise, it's calling then on nothing. It needs to be called on a promise. So, so let's go ahead and fix this, right? So how do we fix this? Well, we first want to return the promise here, and we want to return that as well, and so we'll start with each one of these. All right. There's that. There's that. All right, should be close enough. Excellent. Oh. I guess we weren't supposed to run it. We were supposed to run it, see that it works, and then cool. So we refactored a little bit. So Promise.all is another when you're saying, damn, Dylan, there's what if we want to fire off a bunch of promises and deal with them and we don't care about the order, right? So like maybe we just have a bunch of async things that need to happen and order doesn't matter. And the last one, order did matter. Well, Promise.all will allow us to do that. Promise.all accepts an array of promises as its argument and returns a single promise. So if every promise in the argument array resolves, a single promise returned from promise will represent an array, will resolve with an array containing a resolve value from each promise in the argument array. So you can see here we have Promise.all like so. My promise is then and catch. So maybe you have one that's going to update and then you want to do a get and the get only returns. So, you know, it's not every promise needs to return anything. So our promise is doing so well that we're running low. Our business is doing so well we're running low on memory. We want to reach out to some distributors to see if they have any items we need. We only want to make one restocking order, so only place the order if all of the items are available. Take a look at the provided code. We require in one function check availability. Check availability expects two string arguments, an item, and a distributor. It returns a promise. The function simulates checking that the given distributor has a given item. 80% of the time it will resolve the promise with the item. 20% of the time it will reject the promise with error message stating that the item is available. Also provided two functions. All right, cool. They told us a little bit of stuff. All right. Create three variables, each assigned to a separate promise. Const check sunglasses is equal to a new promise. Check availability, and the first thing is sunglasses, and the second thing is favorite supply. I really should just paste this in here so I don't keep getting these typo errors. Supply code dot as the second argument. All right, the next is check pants. This will also be check availability, except it's going to be pants. And this will be favorite supply co. And thirdly will be check bags. Subtype bags, favorite supply co. Cool. Oh. All right, so we set up our three promises. And now we want to resolve all of them with Promise.all. And it takes an array, because it's a list of promises. So we have check sunglasses, check pants, check bags. All right. Cool, so we set that up, but we're not actually doing anything with it and we're not handling the resolve. So let's go ahead and do that. And then should pass the on fulfill. So we're gonna pass in two functions, two callbacks, so on fulfill. And we're gonna pass in on reject. Let's go ahead and check our work. Oh. That looks all right. Oh. I know what the error is. I think it's because I didn't use catch. Yeah. So I passed it on. My bad. And then we will put on reject in our catch because that's our error. All right. Excellent. And now when we launch our node app.js file, it's checking, 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 and then it returns it all back as a single response here. Items checked, items array. So items checked, sunglasses, pants, bags, right? Concatenates them together. And we have all of our promises that have been returned and concatenated together from our Promise.all. Cool. So we talked quite a bit about promises, and there's a lot of setup and a lot of code here. It's really in the next section we're going to simplify some of this sort of busy work, is what I like to call it, and just we're going to eliminate some of these thens, and we're going to look into async await, which is the ES6 way of handling this, and makes it a little bit easier. So a couple things that you need to remember is that a promise has 3 states. It is pending, meaning it's still going. It is resolved, meaning it was successful, or is rejected. Rejected if there's an error or an issue, right? So we can construct a promise, as we showed with the new promise keyword. Set timeout is similar to a promise in the fact that it's asynchronous. We then will be, it's typically where we pass the success handler. Catch is how we catch the errors, and Promise.all is how we can resolve multiple promises at a time. So up next we'll be talking about, we'll be diving a little bit more into the next section, which should be about async and await. So as always, thank you so much for watching the video. Don't forget to comment, like, subscribe, share, and I'll see you guys next time in the next video. Hey guys, thanks for watching the video. Don't forget to check out my 100 Algorithm Challenge course. Get you prepped for those technical interviews to make sure you get nice offers. I actually just added some new content to it so you can get prepared for those technical phone screens as well. There's a link in the description to get it for just $9.99.